Okay, and now we'll be moving to the next part, the next section, which is finding the area of cross sections. And from that picture, I just want to show that when they built that road there, okay, let me just get the pen to work. Okay, when they built that road there, okay, it was originally a high area, so they've got to cut there, and they've got to cut through, and the low-lying area down here, okay, which is lower than the road surface, they have to put an embankment, get to fill the area. So we have a free slope area, that part there, and we have through cut area. So when we're talking about cross section, when we're looking at, how do we figure out to calculate that section there. So in this case, how we do figure out to calculate the fill section in there. So that's what we be looking or discussing. Okay, that's another figure to show a simple cross section. Okay, there's one cross section there, and there's another cross section at the back. Okay, area from cross sections. When we constructing roads or highways, railway tracks, or any similar constructions that involves alignment, okay, whereby we'll be doing or we'll be making markers along the line, along the alignment at regular intervals. If you could recollect what we've learned in road curve, where you have to mark the center of the road at a regular interval. So when we do that, okay, and when we put the markers in and we find the reduced level of those markers, okay, using any means, either using a detailed survey method or using a leveling approach, you will obtain what we call a longitudinal section. Okay, for short we just say long section. Okay, you will obtain what we call a long section or a longitudinal section. And at the same time, if we add more observations to the left and right of the center line at the marker, on the marker that we make, the regular intervals, the left and right. If we do a bit more leveling or a bit more detailed survey, we will obtain heights. And what we'll be obtaining will be what we term as a cross sections. Okay, so we have long sections, getting the heights information, the height information along the alignment, and the cross sections right angle to the alignment at suitable interval. Okay, what I have there, let me just play the video. Okay, it's a project or a job that I was involved in some time ago, and it's a road improvement project, which means that we need some kind of realignment, and the light colored, okay, are existing road, whereas the lines they are in brown, okay, the existing contour line. Okay, so this is what we have at site, and we'll be designing a road. So the alignment. So if you remember from our lecture in road curve design, so we have to decide the alignment. So the red line here represents the alignment. So in this case, it's a straight line there, connected by a curve there. Okay, so a curve and a straight line. And so what we do next, we will be, once we got the alignment, we'll go to the field, and we'll be marking the center line. Okay, we'll be marking the center line, like so, at a suitable interval. And I think in this case, the interval was 100 meter. Okay, 100 meter. Okay, that's the alignment, that's the center line. Okay. Okay, now once we obtain that, okay, so we can basically get what we call a long section. But to get a more better representation, we then conduct detailed survey along the alignment. So those numbers represent spot height, and if you could see, those numbers or those spots height are made like basically right angle to the alignment. So this represent or looks like cross sections. Okay, so those are the detailed survey with all the heights, or all the spot heights that we have obtained. And I said earlier it was in the manner of looks like cross sections. This is to be a bit more systematic. So based on the center line, we can come up with, in this case, a long section. So a long section basically is a section to the center of the road, and it tells us, in this case, areas that we need to fill, this area there, and all this will be filled, a bit cutting there. Okay, so if I can just pause that for a minute. So if you look there, that will be a cut area, that will be the fill area. Okay, and the magenta line represent a vertical curve, and the red lines represent the grades. Okay, so it says the VIP7 or intersection point 7. So that's the information for the intersection point, the chainage, and the elevation, and so forth. So from the long section, we can come up with, we can see where are the areas of cut, where are the areas of fill, and how do we fit the vertical curve. So that red line there is basically the grade. That's one grade coming there, another grade coming up like that. Okay, so that's what you get from a longitudinal section, or long section for short. Okay, so you've got all the height, the proposed level, height, radius level, as well as the existing level, and distances from the starting point. So that's a long section. Now coming back to the drawing, or the figure that I've shown. Okay, I've told you earlier that we do measurements basically right angle to the alignment. So we're going to produce what we call a cross section. So before that, we have to identify the magenta line there is basically the limit or the right of way. So when we do our cross section, when we do our measurements, we will do it up to about that point. Okay, we don't go beyond that, because there's no point going beyond that. That'll be the outside of the project area. So left and right, we have determined the right of way, so we know now where the spot height that should be made on, or the detailed survey should be conducted. So that's a typical one of the cross section of the alignment. And in this case, the cross section will made at every 25 meters. Okay, so we produce cross sections, and the cross section gives us a very clear picture of where area to be cut is. Okay, that's area to be filled in this case. Okay, the red line represent proposed. There's a slope created, and the magenta line represent the existing surface. Okay, so we'll have cross sections like that. So that's what we'll be looking at. That's so what we want to do. We're going to find out how to calculate the area of this cross section. It might come in various shapes and sizes. You might have areas that needs filling, or you have areas that needs cutting, or you might have sections that have both cut and fill. Okay. Now let's get back to the original drawing. Okay, so once we've got that, we can now see where the proposed road is. So that purple line, the edge of the proposed road. So there's two lines there. Okay, and at the same time, since we know the cut and the fill now, we can come up with the slopes. Okay, the slopes to the left hand side of the highway, or the road that we have just proposed. Okay, so that gives us a complete picture of the alignment with the center of the road, the limit of the road, the cut and fill, the slope that will be created when the road is completed. Okay, so that's cross section, and let me just go to the next one. Okay, long sections are used to design the vertical curve required. So from the slide that I've shown earlier, you could see that from the long section we can come up, or we can figure out where the vertical curve will be, the grades going down and the grades going up, and how long is the vertical section or the vertical curve. And at the same time, it tells us where areas of cut and areas of fill. Whereas cross sections serve as input, or will be used to calculate volume. So we need to figure out, okay, before we're going to start calculating volume, we've got to find out the areas of the cross sections, and there are a fair bit of number to do that. You could either use a mathematical formula, or if you want to go a very simple approximation, grid and counting squares would be good enough. And if you have an access to a planimeter, I would say planimeter would be, the best way to go if you're doing it manually. Okay, this is if you have a map, or sorry, a graphical representation of the cross section, and you've drawn the cross section on a paper, on a plan, and you need to find the area. So I think planimeter will be the best tool to use. Okay, but if you're interested in calculating the cross section, there are formula that you can use, and you can find them in the reference book that I've recommended. So these are just an excerpts from the book, okay, just to show various condition, general condition. We have a level across, two-level section. We have part cut and part fill, and three-level section. So these are the scenarios, the general scenarios, and you got to adapt it in some manner. And if you have a one-level section, either a fill or a cut, okay, you can use that formula there. Okay, the formula there. Okay. Based on the diagram, the W means the width, B means the breadth and the height, and so forth. Okay, so that will be one formula. But if you look at a two-level section, so the formula is a bit more elaborate. That's the formula there, a bit more elaborate. Again, still doable. Okay, you can do it. You can use the formula if you wish. Or if you have a three-level, so that's how it looks like. Okay, you have a level surface there for the road, and first grade one in L and second grade one in K. So that'll be your formula. Okay, and lastly, if you have cut and fill, you have to break them into two parts. One to calculate the fill area and one to calculate the cut area. Okay, so it also depends on what you prefer. Okay, you can use this or you can use a planimeter. But in any case, if you have a digital copy of the sections, you can always find out the area using a suitable software. And most of the softwares now actually will calculate the volumes right away. Okay, if you have nominated the cross sections.
انضم معنا الآن واشترك بالقناة ليصلك كل جديد. YSAG، معا نحو مستقبل مشرق.